Hi there. We looked today in class at increasing and decreasing intervals and how to determine on what intervals my function is increasing or decreasing. So I selected two problems to demonstrate this. The first one is number 1, which says f of x equals x squared minus 6x plus 8. And so looking at this problem, we're wanting to find our increasing and decreasing intervals. Well, the spots at which a function might change from increasing to decreasing, or vice versa, from decreasing to increasing, those spots would be at discontinuities or at critical numbers. And so that's my first step in this process, is I need to determine where are those locations. Where are my discontinuities? Where are my critical numbers? Because that'll be the edges of my intervals, right? That'll be where I might change. Okay. So looking at number 1 here, I have no denominator, no place where the limit wouldn't exist. It's not a piecewise, right? So I have no discontinuities for number 1. Nowhere where the denominator would equal 0. So then the only thing I'm concerned about with this particular problem are my critical numbers. And critical numbers exist when the derivative equals 0. And so we're going to go ahead and take this derivative. We get 2x minus 6, and that equals 0. Adding 6 to both sides, we get 2x equals 6, and so x would equal 3. That's my one critical number. Okay, so then I'm going to go ahead and set up a little testing number line here. And my one possible location where a break in the interval might occur would be at x equals 3. And so on either side of that, we're going to pick a number to test. We want to see what sign do I get for that number. So I'm going to go ahead and pick a number over here. Like left of 3 would maybe be 0. Right of 3 would be 5. And it doesn't actually matter what your testing number is. We don't care what actual value we get. We only care about its sign. Is it positive or negative? And here's why. We're looking to see if a function is increasing or decreasing, right? If a function is increasing, picture it right now, if it's going up on a graph, increasing, that means my slope would be positive, right? Picture a positive slope. That makes my graph go up, makes my graph increase. Okay, on the opposite side of that would be for a graph to decrease. I'm looking for a slope to be negative. Okay. And so when you're asked on what interval is a function increasing, what they're asking you technically is on what interval is my slope positive? Because if my slope is positive, then my graph is increasing. Well, when we talk about slope, what we are concerned with is my f prime. And so that's what I'm going to be plugging my testing numbers into, this 0 and this 5 that I've selected to test my sign, to test if it's positive or negative. I'm going to be plugging that up here into my f prime to determine, do I get a positive or do I get a negative? Okay, well, when I take 0 and I plug it in here, I get a negative number. Which means that my graph, if it's a negative slope, is decreasing. On the other side of things, when I plug in a 5 into that f prime, I get a positive number. And if my graph has a positive slope, a positive derivative, then my function would be increasing. So decreasing and increasing. And again, it doesn't matter what value you get. I don't care that this one happens to be positive 4. I just care that it's positive. Because if my slope is positive, then my graph is going up. My function is increasing. Okay, which brings us to that final step. Now that we've gone ahead and tested our intervals, we know that here on the left, from negative infinity to 3, okay, that is an increasing interval. I'm sorry, that is a decreasing interval. Okay. And then from 3 to infinity, that one is an increasing interval. And again, if you notice, we didn't refer to our 0 and 5 ever in our answer, right? Because that 0 and that 5, those are our subjective numbers. We picked them. They have no real bearing on the final answer. they only help us to highlight what's happening on that interval. They're just a testing number that we've picked. And so they aren't going to make their way into my problem. Into my answer. The only thing that works its way into the answer is that critical number, or if I had a discontinuity, potentially the discontinuity as well. Okay, and so then the other one I've picked here is number 3. We have y equals x cubed over 4 minus 3x. And so the same process here, we're going to start with saying, okay, where are there discontinuities? Are there any discontinuities? And looking at this function, I have nowhere where my denominator would equal 0, so I've got no discontinuities. Okay. So next I'm going to be looking for critical numbers. So I'm going to go ahead and take this derivative. And we're going to be looking, where does that derivative equal 0? Okay, so we're going to go ahead and solve this. We're going to add 3 to both sides. We get 3/4 x squared equals 3. Multiply both sides by 4/3 to get rid of that fraction. We get x squared equals 4, which means x equals plus or minus 2, positive or negative 2. And so in this particular problem, we have more than one critical number, meaning we're going to have more than 2 intervals. Right? You can have as many intervals as the function requires, right? There's no limit on the number of intervals. So I'm going to go ahead and put on negative 2 and put on 2. And then pick our testing numbers here. Okay, so left of negative 2, I could plug in maybe negative 5. In between negative 2 and 2, I'm going to pick 0. Right of 2, I've got 5. And again, I'm plugging this into f prime, or in this case, it would actually be dy dx. Right? But I'm testing it in my first derivative. Okay, so I'm going to take this negative 5, and I'm going to plug it in up here. And when I plug in negative 5 into my first derivative here, I get a positive number, and so I know my function's going up. And I'm going to take 0 and I'm going to plug it in, and I'm going to get a negative number, so I know my function is going down, it's decreasing. And then I'm going to take 5 and plug it into my first derivative, and I'm going to get a positive number. So I know my function is increasing. Okay. And so then we're going to be looking to say, okay, well, where then am I increasing? I'm increasing from negative infinity to negative 2 and from 2 to infinity. I'm decreasing on the interval negative 2 to 2. So that's how we determine increasing and decreasing intervals. And we're going to build on that with our first derivative test, which will be the next lesson.